Good morning, students. The last class we were discussing on the numericals in the electricity chapter. Today we are going to continue the same. So for that we are going to learn how to calculate the equal resistance. For example, if they are given a circuit diagram like this and asking you to calculate the equivalent resistance from this, let's see how to calculate that. First of all, if you get this kind of circuit diagram, you see that the two bubble lines which is given here, and it means they are connected to some battery or anything. For example, this A and B is connected to the battery or whatever it is, so that means it is in a closed circuit. Okay, so if it is connected to a positive terminal, if A is connected to a positive terminal, then a current will flow like this, right? So the current will flow like this, and it flows through 7 ohm resistance. And when it comes and reaches here, there we have two ways. Either the current needs to flow through 4 ohms resistance, or it needs to change the direction and moves through 5 ohms. Where it will go, you will look at it carefully. This area, you see that this is not connected to anything else. That means this wire is in the air. In other words, it can be grounded. So that if it is grounded, then current never passes through this. Will you all understand that? So what happens, the current, after when it reaches crosses the 7 ohm resistance, then it will change its direction towards 5 ohm resistance, and the current will closes this. That means the current cannot flow in this area. That means 4 ohm resistance, the current will not pass. Do you all understand? So it is coming through 7 ohms resistance, and then it changes the direction and it moves through 5 ohm resistance, and then it completes the circuit. So if you watch it carefully, there is same amount of current is flowing through the circuit. If it is same amount of current is flowing through the circuit, definitely it is a series combination. Okay, series combination. Then how to find the series combination? To find the equivalent resistance of the series combination, R1 plus R2. So this is what we do. So what is R1? It is 7 ohms, and R2 is 5 ohms. So what is the answer for this? It is 12 ohms. We all understand the series resistance. So this is how we can find the or calculate the equivalent resistance from this using this circuit. I hope you understand this. We'll do one more example. Let us take another example, and this is another circuit, and we need to find the equivalent resistance from this. Okay, again the same thing. This is A and B. That means this needs to be connected to a battery. So the current is flowing in this direction, right? And it is crossing the 3 ohm resistance, right? Now when it reaches here, then there is a way it can move through this side or this side. If you watch it carefully, when the current comes in this direction, you see that there are 2 resistors are given. That means if resistors are more, then it resists more amount of current, right? So the current needs to escape. Even they don't want to resist more. So what they do, they come directly straight away and avoid this way, and passing through this 5 ohm resistance, and then complete a circle. That means what? For example, suppose if we take this as C and D, they avoid the way C and D, and it is coming passing the C, and then it is completing the circuit. For example, another word I can write it as no current flows through C and D. So we all know that there are same amount of current is passing through all, That means it is a series combination. So I can write it as R1 plus R2, and there are only two resistance are here, so because it's avoided these things, so we have only 3 plus 5. So what is the answer? So we got 8 ohms. So why I gave these two examples, that means you should know how to calculate the equivalent resistance. Now we'll move on to some book example, and this is the 9th question given in your book. So I'm going to read this question and we are going to do this example. A battery of 9 volt is connected in a series with resistors. So 5 resistors are there, 0.2, 0.3, 4, 5 and then 12 ohms respectively. So respectively, that means they are all connected in series. How much current would flow through the 12 ohm resistors? We have 12 ohm also there. They are asking how much current is flowing through the complete resistor. So current is flowing through this, that means it is coming through 0.22, and it is flowing towards this side. So I can make a circuit diagram like this. So I made a circuit diagram like this, and this is 0.2 ohm, because since it is connected positive in this side, so current is flowing through this side, right? And this is 0.3, 0.4, 0.5, and then this is 12 ohms, right? And this is how the current flows. So the question is, and this is a 9 volt battery. Okay, you should understand the question, how much current would flow through the 12 ohm resistance. So when the current is flowing through this, same amount of current is flowing because this is a series combination. So when it passes 0.2, 0.3, 4, 5 and all, there are some resistance will be there. Then they're asking how much amount of current is flowing in this complete circuit, right? Because this is a series combination, so I can write it as R equivalent, in other word series, R1 plus R2 plus R3 plus R4 plus R5. So we can substitute all these things. This is R1, R2, R3, R4 and R5. So we can write that 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohms. So we get 13.4 ohms, and this is the complete equivalent amount of resistance for the complete circuit. So according to Ohm's law, the net voltage which is taken here is 9 volt. So that means V is equal to I R equivalent, right? So we need to find the current I is equal to V by R equivalent, and V, that we know that it is 9 volt which is given here, and R equivalent is just we find that is 13.4 ohms. So when we do this calculation, we find 0.671 amperes of current which is flowing through this complete circuit. So we can say that this is the amount of current which is flows through the complete all the resistance, passing through all the resistance. If it is passing through all the resistance, definitely the same amount of current is flowing in 12 ohm resistor also. That means the current 0.671 amperes of current is flowing through this complete circuit, and same for 12 ohms also, right? So the next question given in your book is, how many 176 ohm resistors, everything must be connected in parallel, are required to carry 5 amperes on a 220 volt line. So there is a current which is flowing in a circuit, that is 5 amp of current, and this is 220 volt. The potential difference is 220 volt, and they are asking if each resistance, for example, I can draw like this. this is for an example. For example, each ohm, that is 176 ohm, that means each resistors are 176. Just for an example, we didn't find this how many resistors we need. Just this is, it should be connected like this, right? And the current which is flowing through this is 5 amp, right? And which is having the potential difference of 220 volt. The question is clear that how many resistors we need, and each resistor is 176 ohm. So what are the things which is given here? We have given that current is 5 amperes, and there is volt, potential difference is 220 volt. So using this, we try to find that what is the equivalent resistance which can be flown through all these complete circuit. So V is equal to IR equivalent. The equivalent resistance, if I want to find, then we can write this, rearrange this formulas like this: V by I. So it can be written like this: V is 220 volt divided by current is 5 amp, right? So we get 44 ohm. This is the equivalent resistance which is flowing through the complete circuit. Okay, complete resistance, that is equal resistance which is seen on this complete circuit. So now what the thing is, find the n number of resistors. We don't know the number of resistors we need to be connected. So let us say that we need n resistor. We don't know how many resistors in this are needed to, and each resistor should contain 176, right, ohms. We don't know that how many resistors. So we can use this formula R 1 by R equivalent, because it's all to be connected in parallel. So 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. We don't know that. N times. How many, that we don't know. N times. So value of each resistors are given as 176 ohms. Value of each resistors are 176 ohm. So we need not to write this as R1 and R2, R3, R4, because they are all different only. We can write it as R1, R2, R3, because we know that already it is, all the resistors are 176 ohm. So we can write it like this: 1 by R equivalent, we write it as R 1 by R plus 1 by R n times, right? So even we can write like this also: R equivalent is equal to n by R. Why I am writing n by R? Because adding all these 1 by R n times, that means multiplying that n by R with n. Will you understand that? Adding 1 by R n times, that means what? Multiplying that n by R with n. So that is why I have written as n by R. So what is n? We need to find n only. So n is equal to R by equivalent resistance. So we can write now resistance, that we know that it is given in a question, that 176, and equivalent resistance that we already find it as, it is here 44 ohms. That 44. So it shows that 4, that is the number of resistors we need, the number of resistor we need to connect are required to carry 5 amperes of 220 volt line is, we need 4 resistor. So we need how many resistors? N is equal to 4 resistor that needs to be connected in parallel. That means it should be like this. Okay, we'll move on to the next question. Our next question is, show how you would connect three resistors, each of the resistance 6 ohm, so that the combination has resistance of one is 9 ohm, another is 4 ohm. So the question is, how you would connect three resistors. So three resistors there, and each resistor, each of the resistors of the resistance is 6 ohms. How, in what combination we are going to connect that? If for example, if we connect, for example, one, if we connect all in series like this, all are having 6 ohms, so our series must be 6 plus 6 plus 6, it comes 18 ohm, and that is also not coming, right? Secondly, if it is connected all in parallel, for example, if it is all connected in parallel like this, so all are in 6, so we write it as 1 by Rp is equal to 1 by 6 plus 1 by 6 plus 1 by 6. The answer also comes as Rp is 2 ohms. That is also not coming, right? So there is another way we need to think how need to be, what kind of a combination we can use. So firstly we can try this to find the resistance, equal amount of resistance as 9 ohms and so how to do this? So first we can say that two resistors are in parallel, so we do one thing, we connect two resistors on parallel. So like this, one, another is like this. So what will happen? So these are 6 and another is 6. Let's try what happened. Parallel means Rp, 1 by Rp, so it comes 1 by 6 plus 1 by 6, it comes 2 by 6. In other word, Rp is nothing but 3 ohms. So now this is becoming 3 ohms because it is Rp, because they both are connected in parallel. For example, if we connect one in series like this, two are in parallel and one in series, and this is also having same resistance, that is 6. So therefore R equivalent is equal to 1 is already we did, that is plus one more, that is 6, we have connected series, right? That means R equivalent in series, Rp, already we know that it is 3 ohms, that plus 6 ohms. This we know already, it is 3 ohms plus 6 ohms, totally 9 ohms. So 1, 2 in parallel and 1 needs to be connected in series. Okay, we have another one, equivalent resistance. Here now another one is 4 ohms. How it comes? Now what we do, we connect two resistors are in series. How it's in series? For example, 1, 2, this is also 6 and this is also 6. Okay, so if it is series, then we all know it's easily Rs is equal to R1 plus R2, that is 6 plus 6, which is equal to 12 ohms, right? And what about that? And one is connected in parallel, one is connected in parallel. Thus we know already these two, it is 12 ohms, right? Because they are connected in series. So therefore 1 by R equivalent, which is equal to 1 by RS plus 1 by 6. Sorry, it's plus 1 by 6 because it's in parallel. So what it comes? It comes 1 by 12 because already we know that RS is 12, and then 1 by 6. So what it comes? It is calculation 1 by 4, right? 1 by 4 is nothing but R, which is equivalent, which is equal to 4 ohms. This is what we find. Clear? So these are the examples, some which is given in your book, exercise problems which is given in your book, and we tried 3 examples today, that is 9, 10 and 11. So what we are going to do is, the student, you do the remaining examples by yourself. If you have any doubt, please ask me through a message. Clear? And stay in your home, stay safe in your home, and do all these exercise problem by yourself. And you have any doubt, please feel free to ask the question. And thank you, students. Have a nice day.